In a previous video, I described the concept of encapsulation, one of the major concepts of object-oriented programming. There are two other concepts that you need to master to be a great object-oriented programmer, and they're named inheritance and polymorphism. I'll describe them here. Inheritance means that there's a relationship between classes in your application. An inheritance relationship lets you inherit or extend functionality from one class to another. In the world of C++, there's multiple inheritance. A single class can inherit functionality from multiple other classes. But in Java, there's only single inheritance. Each new class can extend or inherit functionality from only one other class. This actually makes it a lot easier to manage your code, because if you've created an inheritance relationship and you run into a bug, that bug can either be in the class you're working with or in the class that you inherited from, but the issue has to be somewhere in that very linear path. There are a number of ways to describe an inheritance relationship, and they're just different vocabularies. You'll hear some developers describe the relationship as a parent-child relationship, where the parent has the functionality and the child is inheriting. You'll also hear the terms base and derived, where a base class has the functionality and the derived class is extending it. In the world of Java, the terms that are most commonly used are superclass and subclass. The superclass has the functionality and the subclass is extending the superclass. And again, each subclass in Java can only have one superclass. In fact, even if you don't explicitly extend a class, all of your classes are extending another class, a superclass. There's a special class named object with an uppercase O, and this is at the top of the Java inheritance tree. If you don't explicitly inherit from some class, you're inheriting from object automatically. So that's inheritance. Polymorphism is the last important term to understand. Polymorphism means that when there's an inheritance relationship between a superclass and a subclass, you can deal with an object that's instantiated from the subclass either as its native type, the subclass, or as its inherited or extended type, the superclass. To do this, you declare the object, and instead of declaring the native data type, you declare the superclass type. If it's a class that you're instantiating by calling a constructor method, you call the constructor method from the subclass, but you use the data type of the superclass. When you've done that, it becomes possible to take that object, which you declared as the superclass, and pass it to any method that's expecting an instance of the superclass. When you have an inheritance relationship, this can give you enormous flexibility in designing your code. Let's visualize an inheritance relationship. Let's imagine a class named Olive. Well, there are many kinds of olives in the world, and so you might declare a superclass named Olive that has functionality that's common to all olives, but then you might create multiple subclasses, each representing one particular kind of olive. This is how we would diagram the relationship, with an arrow pointing to the superclass. That arrow means that the subclasses are extending the functionality of the superclass. The superclass is Olive, and all the others are the subclasses. We call this single inheritance because each subclass can only have a single superclass. But as you can see, a superclass can have many subclasses. Superclasses don't need any special code. Any class can be a superclass. And all of the fields and methods of that class can be inherited unless they're marked as private. You'll see that it's very common to set fields or data values as private in a class, and methods of a superclass as protected or public. Private means that only the superclass can deal with the field directly. Protected means that a method can be called either by the superclass or by its subclasses. And public means that those methods can be called by anybody. Let's take a look at code of a sample superclass. This might be the class Olive. The class Olive might have a couple of fields or data values. I've declared a double value called volume and a Boolean value called crushed, which is initially set to false. I have a method called getVolume, and the logic of that method says if the value crushed is true, then return the volume, and otherwise return 0. This is using the ternary operator, a shortened conditional syntax. There's a protected method named setVolume. It's protected so that it can only be called by the class itself or its subclasses. And there's a public method named crush, which basically says this olive has been crushed. The fields or data values are marked as private. Only the superclass can deal with them directly. The getVolume method, which is a getter-accessor method, can be called by anybody in the application. The setVolume method, the setter, can only be called by the class itself and the subclass, and the crush method is declared as public. Now again, this is just one way of designing the code. It follows some standard recommendations in Java, like keeping private data private, but you could choose to do it differently. Now, the subclasses that extend the superclass. In order to extend a superclass, you declare the class in your Java file, and you use the extends keyword and reference the superclass. It might look like this. I'm placing my class into a package named olives, and then I create the class named Kalamata, and I use the extends keyword and then the superclass name olive. The subclass implementation might have a lot of details, but here's one small example. As the subclass is constructed and its constructor method is called, it would be responsible for setting its own volume, or the amount of oil it's capable of producing. So, within the constructor method Kalamata, which matches the name of the class itself, it calls this.setVolume too. SetVolume is a protected method, so the subclass can call it. But the actual data it's affecting is stored in the superclass. It's hidden from the rest of the application. Another subclass of the same superclass would call the setVolume method also, but it would set its numeric volume differently. So now Liguria is saying, I can get 5 units of oil, and Kalamata is saying, I can get 2 units of oil. They're both calling the same method, they're both using that same hidden data that's in the superclass, but they're determining what the actual value is. When you go to the main class code, you can now say, I'm going to declare an array of olives. Olive bracket bracket means multiple olives. But then when you actually declare the instances of the objects, you use the constructor methods of the individual subclasses. I have an array with 2 Kalamatas and 1 Liguria, but they're all olives because of the inheritance relationship. I could then create an instance of the olive press, call the getOil method, and within that method, it would then go and call the appropriate methods of the olive object, and for Kalamatas it would get 2 units, for Ligurias it would get 5 units, and so on. The rest of the application does not need to know the mechanics of how the volume is being calculated. All the top-level application has to do is say, I've got these 3 olives, and they're of these types. Go ahead and crush them. The actual mechanics are hidden within the class implementations. This idea that you can create an instance of a class by referring to its uniquely named constructor method, but then take the object and fit it into a data type of its superclass is polymorphism at work. You're taking an object that has a native type and you're saying, I'm going to use it as though it's its supertype. That's polymorphic, and it allows you to build really elegant applications. Within the implementation of the olive press, it would simply loop through the olives and call the methods, it would get the oil, it would add that to the olive oil, and the end result would be a correct calculation. The olive press doesn't need to know how much oil you get out of each olive, and it doesn't even need to know that there are all these different kinds of olives out there. From the point of view of the olive press, there's only one kind of olive, an olive, and you can crush it and you can add it to the oil. The details are hidden within the implementation. So that's the idea of inheritance and polymorphism. In the rest of the videos of this chapter, I'll show you how to implement inheritance and put it to work polymorphically in your applications, and then in a later chapter we'll go on to more advanced concepts using constructs called interfaces and abstract classes that also add to the inheritance model of Java.